Okay, we're going to look now at empirical formula determinations from grams. So we have 0.361 grams of calcium and 0.639 grams of chlorine, and we're going to determine its empirical formula. So we cannot compare grams, so we need to convert these into moles. So that's going to be a one step since the word mole is in our question, although it doesn't explicitly state it, of course. So, but that's our job, is to convert each of these into moles. So 0.361 grams of calcium, and we want to get this to equal moles. And of course, one stepper because it is a mole conversion. And then we have 0.639 grams of chlorine. And we want to convert that into moles. Okay, to do that, we are multiplying times, I already got the time symbol there, so I don't need that again. So we'll times it by 1 mole of calcium. We'll go to the periodic table to get its mass. That's 40.08 grams of calcium. And likewise, times 1 mole of chlorine over its mass on the periodic table, 35.453 grams of chlorine. Okay, and that equals 0.00901 for this one here for calcium, and 0.0180, okay, moles, okay, for our chlorine. So now we can make a comparison. We know that this one is larger than this one over here. So we do a mole ratio then. So we're going to divide each of these by the smaller amount. Divide this by 0.00901. And that's going to give us a 2. And this will give us a 1. Okay. Now this one here gives you an exact 1. This one's like 2.000 and it goes on. So that's very, very close to 2. We know that we can round that to a whole number then. Okay, so likewise, this one here is 1 exactly. We know we can round that to a 1 exactly. So the formula then is 1 calcium for every 2 chlorine, so that's CaCl2. Now we can compare this to when we did this by crisscrossing the charge method. I'll do that over here. We look up calcium from the periodic table. It's calcium plus 2. And chlorine is minus 1. We crisscross the charge. There's a 2 there for it then. We don't write the 1s down there. So we show excellent agreement between these two methods. Again, this was our first semester method. This is our second semester method, I guess. All right, let's try another one. We have a compound made of potassium, chromium, and oxygen. We're going to do the same thing. We're going to convert these into moles, 0.266 grams of potassium. And then we're going to go times 1 mole of potassium. We look at its mass up at the periodic table. It's 39.0983 grams of potassium. And that, of course, is going to equal moles of potassium. Okay, that is going to be 0.00680. So 0.00680. Let's do likewise with our chromium, 0.353 grams of chromium. We'll times that by 1 mole of chromium. Okay, and we got to go to the periodic table to look at chromium's mass, and it's 51.996. And that, of course, is going to equal our moles of chromium. And that is 0.00679, 0.00679. Notice I'm keeping at least 3 significant digits in these. It'll help when we round in the end. And then lastly, we'll do the same for oxygen, 0.381 grams of oxygen, times that by 1 mole of oxygen over 15.9994 grams of oxygen. And of course, that's going to equal our moles of oxygen. That's 0.0238, 0.0238. Okay, then what we're going to do, again, the same thing. Once we get in moles, we'll divide the least moles into all the largers. This one looks like it's the least, so we're going to divide it by itself. I'm going to see if I can sneak this in here, 0.00679. Okay, that's actually going to be a 1. This will be divided by 0.00679. That's going to become a 1, very close to 1. When we divide this one, I'll write it down here, by 0.00679, we actually get 3.5. This is not roundable to a whole number. You're tempted to go, oh, that's 4 or that's 3. No, this is not close to a whole number. It's halfway in between. So what this means is we have 3.5 atoms of oxygen. Of course, that's not possible. We need all of these to be whole numbers. So I think to myself, what can I multiply everyone by to get this to be a whole number? And the answer, of course, is 2. So we're going to times each of these by 2. Because when I do that, I'll get a 2, and this one will convert into a 7. So our formula then is K2Cr2O7. So make sure you watch out for when you've got to actually maybe double, or sometimes you got to triple them to get things to become whole numbers. So watch that very, very, very carefully when you do it. Now this, of course, is a polyatomic ion. If we do the crisscross recharge method, this is K plus 1. Dichromate is Cr2O7 minus 2. When we crisscross the charge, we bring a 2 down here, and a 1 would go there. We don't write 1s. So once again, we see the crisscross recharge method has excellent agreement.